Imagine a world where we could alter our genetic makeup. Would you be eager to embrace it, or would you hesitate? Let's journey back in time to the year 1973, when the first transgenic organism was created, marking the dawn of genetic modification. This was the year when scientists successfully inserted antibiotic resistance genes into a bacterium called Escherichia coli. The creation of this transgenic organism was a scientific breakthrough, laying the groundwork for the field of genetic engineering. Fast forward just a year later, the first transgenic animal came into existence, a mouse. This accelerated the use of genetic modification across all areas of biology, from creating bacteria capable of breaking down crude oil to increasing the shelf life of tomatoes. The applications of genetic modification seemed to know no bounds. Then came a revolutionary moment in the year 2012. A gene editing technology known as the CRISPR-Cas9 system was introduced. This remarkable tool kickstarted the rapid development of gene editing technology into the widely practiced technique that it is today. CRISPR, which stands for Clustered Regularly Interspaced Short Palindromic Repeats, paired with the Cas9 enzyme, gave scientists unprecedented control over the DNA of living organisms. Thousands upon thousands of research papers on CRISPR are published each year, and the rate increases annually. It seems that the applications of CRISPR are boundless, with geneticists worldwide keen to apply this technique to a myriad of scientific questions and challenges. From the humble beginnings of a transgenic bacterium to the sophisticated CRISPR-Cas9 system, the field of genetic modification has come a long way. We moved from merely observing the genetic world to actively rewriting it. And as we continue to explore this brave new world of genetic modification, the question remains, how will we use this powerful tool in the future? The applications of CRISPR seem limitless, with geneticists worldwide eager to utilize this technique. What was once a concept limited to the realms of comic books and movies is now becoming a reality. In the world of science, the impossible often becomes possible, and so it is with genetic modification. Where once geneticists were content with tinkering with the DNA of bacteria, now they have turned their attention to a far more complex and controversial subject: humans. This shift from the microscopic to the macroscopic is not just a matter of scientific curiosity, but a necessity driven by the urgent need to treat and hopefully cure genetic diseases. In laboratories around the world, researchers are exploring how they can use the power of CRISPR, a revolutionary gene editing tool, to rewrite the code of life. Their focus is not on creating superhumans with extraordinary powers, but rather on giving people with genetic disorders a chance at a normal life. Take, for instance, the case of cystic fibrosis, a life-shortening genetic disease that affects the lungs and digestive system. By correcting the faulty gene that causes the disease, scientists hope to not just treat its symptoms, but eliminate it altogether. And it's not just cystic fibrosis. From sickle cell anemia to Huntington's disease, the list of genetic disorders that could potentially be treated with gene editing is long and growing. But while the science is promising, it's not without its challenges. Editing the human genome is a complex task, fraught with ethical and technical hurdles. Still, progress is being made, and some gene therapies are already being put to clinical use, marking a significant step forward in the field of genetic medicine. Today, individuals are being given abilities beyond what their original DNA bestowed upon them, marking the birth of the first genetically modified humans. Yes, these individuals might not have super strength or the ability to fly, but in their own way, they are superheroes. Living proof that science is turning the fiction of genetic modification into a life-changing reality. Consider the power of invisibility, not as a superpower, but as a life-saving medical advancement. In the realm of organ transplantation, the immune system plays a pivotal role. It's our body's knight in shining armor, our first line of defense against bacteria, parasites, and viruses. But when it comes to patients who have undergone a transplant, this hero can turn into a villain. The immune system, in all its complexity, is designed to protect us from foreign invaders. So, when a new organ, perceived as a foreign body, enters the system, it triggers an immune response, leading to the potential rejection of the transplanted organ. This is where the power of invisibility comes into play. the ability for transplanted cells to become invisible to the immune system, thus preventing rejection. Enter the world of CRISPR, a revolutionary gene editing technology that has been making waves in the scientific community. With its potential to rewrite the genetic code, it's becoming a beacon of hope for transplant patients. Researchers are exploring how CRISPR could be used to modify the genes of the transplanted organ, making them more compatible with the recipient's body. In essence, it's like giving the organ a cloak of invisibility, allowing it to slip past the watchful eyes of the immune system. Imagine a future where transplant rejection is a thing of the past, where organs can be seamlessly integrated into the body without the fear of rejection. It's an exciting prospect, and it's one that researchers are tirelessly working towards. While we may not have a 100% effective way to prevent rejection yet, the use of CRISPR in humans promises a future where this could be possible. The power of invisibility, once the stuff of comic books and science fiction, may soon be a reality in the world of medicine, thanks to the revolutionary potential of genetic modification. As we stand at the precipice of a new era in human evolution, one question looms large. How far is too far when it comes to altering the human genome? The potential benefits of widespread genetic modification in humans are tantalizing. Imagine a world where we could eliminate genetic diseases, enhance human capabilities, or even extend our lifespan. But as with any powerful technology, genetic modification carries significant ethical implications. Consider, for instance, the potential for inequality. If genetic enhancement becomes a commodity available to those who can afford it, could we inadvertently create a society of genetic haves and have-nots? We might also ask ourselves whether it's right to make permanent changes to the human genome that will be passed on to future generations, potentially without their consent. Then there's the question of what it means to be human. If we start altering our genes, do we risk losing something essential about our humanity? Or could this be the next step in our evolution, a way to adapt and thrive in a rapidly changing world? These are not easy questions, and there are no simple answers. But one thing is clear: as we move forward with genetic modification, we need stringent regulations and guidelines to ensure the responsible use of this technology. These should be developed through open, inclusive dialogues that take into account a wide range of perspectives and values. The scientific community has a crucial role to play in this process. Researchers must commit to transparency, sharing their findings openly and honestly. They should also engage in ethical debates, contributing their expertise while also listening to the concerns and insights of others. At the same time, we all have a role to play in shaping the future of genetic modification. We need to educate ourselves about this technology, engage in discussions about its use, and advocate for policies that reflect our values. As we continue to push the boundaries of what's possible with genetic modification, we must tread carefully, balancing the immense potential of this technology with the ethical considerations it presents. In this whirlwind journey through the world of genetic modification, we have traversed from its humble beginnings to the exciting possibilities it holds for our future. We embarked on this journey with the birth of genetic modification in the early 70s. A simple bacteria, Escherichia coli, was our first stepping stone, leading us to create the first transgenic animal, a mouse. We then witnessed the grand entrance of the CRISPR-Cas9 system in 2012, a game changer that sent ripples through the scientific community and kick-started the rapid development of gene editing technology. The shift from bacterial to human genome editing marked a significant milestone in our journey. We saw how researchers, instead of settling for old-hat techniques, dared to delve into uncharted territory, exploring the potential of this technology for therapeutic advantage. The focus of genetic modification research moved towards the treatment of genetic diseases, leading to laboratory advances for multiple disorders, some of which are already being put to clinical use. Then we arrived at a reality that still seems like fiction: the advent of genetically modified humans. Individuals born with certain genetic mutations are now being given a new lease on life thanks to gene therapy. They are the first of their kind, their DNA altered not to create mutations, but to fix them. By doing so, they are given abilities above those that the DNA they were born with gave them, becoming the first genetically modified humans. Looking ahead, we pondered over the future implications of this technology. With trials at various stages, from in vitro to animal models to early clinical use, the therapeutic use of CRISPR in humans is likely to increase as more successful and beneficial effects are demonstrated. These modifications may not give individuals superhero-like powers, but to those with an illness, these abilities could be life-saving. As we continue to unlock the secrets of our DNA, we stand to not only transform our lives, but potentially the very course of human evolution.